Dear students, in last classes we learned how to prepare a discrete frequency distribution and continuous frequency distribution. In that we learned both inclusive type of class interval and exclusive type of class interval. And today we'll discuss next level, that is a special kind of frequency distribution which is called as bivariate frequency distribution. Bivariate frequency distribution. So what is this bivariate frequency distribution? So here, when in certain cases, some situations, we have to study two different aspects belongs to one particular things only. So we have to study them simultaneously. For example, height and weight of the persons. So here height and weight, they have interrelated. They are depending on each other. Even medical fields, they give a list where up to what height what should be the weight of the persons if he or she should be healthy. Then even growth of the baby will be measured in terms of height and weight. At what age the height should be how much and weight should be how much. So if you consider these two are important and they are interrelated. And husband and wife age. So what is the husband age and what is the wife age? Mother's age and number of children's. Import and export. Income and expenditure. So these such things will be studied simultaneously. So they may be taken individually one can study, but if we take them together, so it is helpful to study further, to analyze something here. So in such cases we take both. How do we prepare here? So here preparation is simple as a continuous frequency or discrete frequency distribution, but only is in the table we take both aspects. So in discrete or continuous frequency distribution, just we were taking the data in one column, so belongs to wages or marks or whatever. So we are writing the either discrete series or continuous class interval we were writing, and in next column we were writing tally marks and we are counting them, and we are writing the frequencies, number of observation for that particular class or individual discrete observation. So here instead of one set we take both set. So in row we take one data and in column we take another data. If you take export here and we take import here, if you take babies, number of babies here, we take age of mothers here. If you take income in rows and we take expenses in column. If you take husband age in rows, wife age in column, or maybe vice versa, interchange depending on the data and requirements. So let us learn this by studying a problem. And here one data is taken here, means another data will be taken this side. So if we consider this as x and column wise we consider it as a y data, and in the box by studying both classes simultaneously we mark tally mark in individual cells, and finally we count and write the frequencies. And let us take a problem from the textbook and study it. So from the page number 43, example 2 I am taking here. The data given below relates to the height and weight of 20 persons. Construct a bivariate frequency table with class interval for height as 115 to 125. So 115 to 125, 125 to 135. So they have mentioned here clearly. So what should be the class of for height of the persons? And next data is weight. So weight also they have mentioned here, weight as 62 to 64 and 64 to 66, so on. So if certain things about the classes or class width or number of classes or beginning lower limit of the class, if such things are given, we have to follow that instruction and we have to construct the frequency table here. So that they have mentioned here. And in the last classes we have discussed that what are the rules to prepare a frequency distribution, and there it is mentioned that the first class, lower limit of the first class should be multiple of 5, and here it is not multiple of 5. So in certain cases it is not possible to follow the instructions there. So if you take width 5 or first limit as a multiple of 5, then that 1 or 2 classes may be left blank here. When data is short and it lies within certain limits only, then it is not possible to follow all the instruction, but we can follow certain instruction here. So number of classes, minimum number of classes should be 4, maximum number of classes 15. So that we may follow here. If we leave first class lower limit should be multiple of 5. If you take that multiple of 5, then here we may not get minimum 4 classes also. We may get less than 4 classes. So if one is missed, another rule we follow here. So as the investigator want to present the data in this format only, then we have to do that. And here before going to that, once again, if such things are not given, so what should be the width, what should be the class interval? So if such things are not given, again we have to follow the Sturge's rule and find the number of classes and width of the class, then prepare the class interval. And here already they have mentioned, for just we need to check here maximum limit. So maximum height and maximum weight of the persons given in the data. So in this data given, the height, maximum height of the person is 170. 170 is the highest height. So that means here if we follow this up to 165 to 175 should be the last class. So I think we get 6 number of classes here. Then weight, highest weight is here 71 kg. So 71 kg, and if you follow these class intervals, so I think 70 to 72 will be the last class. So we may get 5 to 6 classes here. So let us prepare the table and plot this data into the bivariate frequency distribution. So here weights of the persons, and in the rows we take height of the persons. And here heights start from, as they mentioned in the book, 115 to 125, 115 to 125, 125 to 135, 135 to 145, 145 to 155, 155 to 165, and last 165 to 175. As the highest weight is 170. And weights, class interval for weights, as they mentioned, 62 to 64. So let's start from 62 to 64, 64 to 66, 66 to 68, 68 to 70, 70 to 72, and last class is 70 to 72, as the highest weight is 71, which lies in the 70 to 72 class. And these two columns for total frequency. So frequency of height we get there, and here frequency of weights we get in these rows. Now let us start how to continue here, how to take both. So in the problem, if you refer in the book, you can observe that simultaneously for all 20 observations, all 20 persons, height of each person along with weight they have mentioned here. First sample, height of the sample is 170 and weight is 70 kg. So height, first come to height. So height is 170 centimeters. So where it comes in this class intervals? So 170 lies in 165 to 175 class, and weight is 70. So here weight in which class it will fit? So 68 to 70, but as it is the exclusive type of class interval, it doesn't lie under this, so it goes to next 70 to 72. So come down from in this row, in this column, and go forward in this row. So where it lies? So here 70 kg and 170 here. So mark here one tally mark, not 1 2 3 number, tally marking. So this is how we have to look for both simultaneously, height and weight. So 170 centimeter height, 70 kg weight, both lies in this cell. And the next one is 135 and 65. So height is 135 centimeters. So here also 135 is there, here also is there. So as it is exclusive type, we go to next class, 135 centimeter, and weight is 65 centimeter. So 65 centimeter lies in 64 to 66. So come down from here. So in this cell we mark one tally mark. And next height is 136 centimeter and 65 centimeter. So 136 lies in this one, and weight is 65 kg again. So again it lies in the same class. Next 137 and 64. So 137 also comes in this row itself, and 65 kg in this column itself. So same cell again. And next is 148 and 69. So 148 lies in 145 to 155, and weight is 69 kg. So 69 kg lies in 68 to 70. So in this row I mark it. Next 121 centimeter and 63 kg. So 121 centimeter in the first row, 115 to 125, and weight is 63 kg. So 63 kg in the first column again. So here I mark. Next 128 centimeter and 70 kg. So 128 in this class, 125 to 135, and weight 70 kg. So that comes in 70 to 72 here. And next 143 and 71. 143 lies in this class, 135 to 145, and the weight is 71 kilo. So straight from here 71 in this cell. Next 129 centimeter and 62 kg weight. 129 in this 125 to 135, and 69 weight lies in this. So here I mark. Next 163 centimeter, 70 kg. So 163 lies in 155 to 165, and weight 70 kg. So 70 kg here it comes. Next 139 kg and 67 kg. 139 in this and 67 kg lies in this column. And next 122 centimeter, 63 centimeter. So 122 in first row, and 63 kg again in first column itself here. Then next one is 134 centimeter and 68 kg. So 134 centimeter in the second row, 125 to 135, and weight is 68 kg. So 68 to 70. And next is 140 centimeter, 67 centimeter. 140 lies in 135 to 145, and weight 67 kg. So here we mark it. 66 to 68, then 132 and 69. So 132 in 125 to 135, and weight is 69 kg. So that comes here 68 to 70. Next 120 centimeter, 65 kg. 120 centimeter first row, 115 to 125, and weight is 65 kg. So 64 to 66 here. And next is 148 centimeter, 68 centimeter. 148 comes in 145 to 155, and weight is 68 kg. So 68 to 70 kg here. And next 129 centimeter, 67 centimeter. 129 lies in 125 to 135, and 67 kg comes in 66 to 68. Last observation is 152 centimeter and 67 kg. So 152, so it lies here 145 to 155, and 67 kg, it lies in 66 to 68. So here is the last marking. Now let us make the total. So first one, make total in individual cells, then we go for rows total and columns total. So first here 2 tally marks are there. So 2, 1, 1, here 3, here 1, 2, 1, 3, 2, 1, 1, 1, and 1. Now make the total for each rows. So 2 plus 1, 3, 1 plus 3, 4, 1 plus 2, 3 plus 1, 4, 3 plus 2, 5, 1, 2, 3, 4. Now columns, sorry, row totals. 2 plus 1, 3, 2, 1 plus 1, 2 plus 3, 5 plus 1, 6, 3 plus 2, 5 plus 1, 6, 1 plus 2, 3, 1, 1. Now make the total, final total. So 3 plus 4, 7, 7 plus 4, 11, 11 plus 5, 16, 16 plus 4, 20. Now this side. 3 plus 6, 9, 9 plus 6, 15, 15 plus 3, 18, 19, 20. So both the side total is 20. That means we have marked all the observation without missing any single value here. So this is how to prepare bivariate frequency distribution. And here we need to remember the classes are taken depending on the kinds of data. If it is possible to take a continuous frequency distribution, so we can take class intervals here, either inclusive or exclusive, depending on how they have mentioned there. And if it is possible to take discrete frequency distribution, then take each individual value. For example, another table we can prepare here for number of childrens to the mothers of different age groups. So age groups we can take in class intervals, and number of children we can take in discrete order, 0, 1, 2, 3, 4, like that. So such table is there in the textbook. We'll solve it in next classes.